Hello. In this presentation, we demonstrate the practical implementation of IDMO, Inter-Domain Management and Orchestration, integrated with amarisoft core and radio access network stack. On the hardware side, our deployment features the amarisoft stack running on a standard PC, connected directly with an USRP B210 software-defined radio. This setup establishes a live radio link to our user equipment, which will be receiving a video stream. To achieve that, IDMO will be used to control this setup. As illustrated in the system architecture, the system allows an intent owner to submit high-level requirements via REST-based intent gateway. The IDMO core processes these requests and communicates with domains via a management bus realized with Kafka. This bus distributes commands to specific domain service adapters, which dynamically control the underlying domain management orchestrators, in this case, our core network module, alongside separate 4G and 5G RAN instances. Now we shift to the live demonstration environment. We start at the IDMO dashboard designed to provide basic real-time visualization of our managed infrastructure. In the next window, we mirror Samsung user equipment screen and observe service mode statistics. The center and right panels track the active amarisoft system services, terminal logs, and our WebSocket-based metrics collector. The demonstration officially begins when 3 distinct domain service adapters registers within the IDMO ecosystem. Upon receiving an intent, the IDMO autonomically triggers the deployment of the required network services. The amarisoft core and RAN components are dynamically instantiated, activating a 4G cell over the software-defined radio hardware. The mobile device after some time detects the signal and attaches to the 4G network on band 4. In the meantime, PC with amarisoft pings mobile phone and reports measured values. Initially, the metric collector records a baseline idle state with minimal throughput. To evaluate the system under operational load, we launch a video stream on the mobile device. To test the self-healing of our framework, we now introduce a critical network anomaly by executing a shutdown of the 4G cell. The amarisoft service immediately shifts to an inactive state. The IDMO infrastructure flags the loss of telemetry and removes the failed service from the operational registry. In response to the service disruption, the IDMO framework evaluates available alternatives and commands the deployment of the 5G cell. A new service is created in the similar way as previously. A 5G cell becomes active on band N5. The user equipment connects to a newly created 5G cell. Telemetry collection is restored, verifying a stable link as live ping metrics populate the dashboard once again. With the 5G data link active, the video stream successfully continues playback, proving the concept of automated recovery mechanism. To conclude the lifecycle demonstration, we trigger a final controlled teardown of the remaining 5G infrastructure. The services are terminated and the dashboard updates to reflect a zero load state, while the mobile phone reverts to a non-service status. This completes our demonstration of the Unity 6G framework's ability to dynamic network orchestration.